enter this equation. So the first thing we're going to do is I'm going to use the go-seek method. Okay, so the go-seek method, we have C. C is whatever we want to find. We enter this as 0.4 for now. Okay, it's arbitrary numbers. So this is the inches. Then we have the first term is equal to 10e to the power 3 times by pi squared times by 0.4 power of 6. Okay, so to be a good programmer, make sure always check with your what? With your calculator that you enter the expression correctly. Okay, if you enter wrongly, you're in trouble. 40425. Okay, so that's the first expression. Second expression is 6.25 times by C power of 2. So it's 1. So 0.4 squared times by 6.25 is 1. That's correct. And then the next one is equal to 360 times by 0.4. So 360 times by 0.4. There's 360 times by 0.4. And then the last term is 17 point what? 73732 e to the power 3. Okay, so the whole thing will be equal. So equal this minus this minus this minus this. Okay. So the easier way to do it, which I've shown you guys before, is you go to data, right? You go what if, and we go to go seek. Okay. So set cell is this cell that we want to set. This cell, we want it to be equal to 0 because the expression is equal to 0. And you want to change the C term and you just go okay and you just wait and holy shit. Okay. Sorry. So what do you see? It's the right value this time. So the number is what? 0. What? 75 what? 33. Okay. So this is using the go seek method. The other method is using the what? I thought I should get minus. When I did it at home, I got minus. Bear with me, okay? If I put 1, what will happen? I do apologize. No cooking show fail again. Yes. You think so? What did I put wrong? I put wrongly, yeah? Ay. Yeah, you're right. Muchas gracias. 177. Wait. I can't read today. 17.732 E3. Is it better now? Yes. Okay, let's do it again. Where are you? Who spot a mistake? 1 pint of beer. You get it tomorrow, okay? So go seek again. This is equal to 0 by changing cell, and there we go. Bloody hell. Wait. It's embarrassing for me. Okay, wait. What if go seek? It should not work at all. Change cell, boom. Gee! Okay, so ladies and gentlemen, I don't know why it worked. Okay, it should not. But can you see the values are different? Did I enter the expression correctly? Wait, I did. But can you see what's the answer now? Yes or no? All right, let me try another method is by using, so I'm going to copy everything. And we are going to use a solver. Okay, so 0.5. Okay, no, not here. So I'm going to enter C is equal. It should not work at all. It did. Pardon my French, son of the bitch. So you click to solver, right? And you want this value over here to be at its minimum. And then you want to change this value and you press solve. No, the numbers are off. So this is a wrong answer. So you put cancel. You go to solver again. The value must be equal to 0, not at its minimum. Sorry, it should not be minimum. 0. Change of B10 and you press solve. Okay, this might not work, but let's try. Ah! There you go. The answer is the what? The same. I do apologize. When I tried at home, I had the negative answer like the what? Like the calculator. Are we clear? So the roots, what we are finding is the roots, yes or no? Right? C, the diameter has to become a what? A positive what? Number. Are we clear? Okay. So I showed you on our calculator, the value is what? It's negative. Okay. It's wrong. Are we clear? By right, it has to be what? Positive. Okay. So if this question will be coming out for the exam, I will accept your negative value because by no means you have access to any what calculator at that moment of time. Okay, right. So after you got this number over here, we are going to check. Okay, so based on von Mises criteria, we need to check. Any questions so far from anyone? We're okay? We're okay, yeah? Yes. Say it again. Tresca, we do everything in Tresca. You don't mix both of them. Okay. So now we have to check that when C is equal to what? C is equal to 0.7493. Right? We are going to check that stress 1 and 2 must be within plus or minus 100 times 10 to the power 3 psi. Okay, so we have to check this. So to check 1 and 2, the expression that we're going to use is equal to minus 2500 over 2 pi c squared minus by 72123 divide by 2 pi c cubed. And then we have to do plus minus and then square root the whole thing again. And this will be equal to minus 2500 over 2 pi c squared minus 7200. So it's basically the equation that we have used before. 2 pi c cubed. And this thing is squared plus by what? 55200 over pi c cubed. Okay, squared. So once you get here, you just enter C as this value over here. I'll not waste your time. It's 8.238 times 10 to the power 3 plus or minus, and then the whole thing will be 28 238 times 10 to the power 3 squared, and then you have plus of 42.203. Okay, so this will come out to be minus 28.238. Okay, plus or minus 50.739. By right, this should be 50, but we have 50.739 because of what? We did some rounding. Are we clear? Okay, we did some rounding. So what we see over here, the stress 1 is 79.017 times 10 to the power 3 psi. And the next one is 22.541 times 10 to the power 3 psi. So both values are within. Okay, so both values, if you look down here, so we can have 100 times 10 to the power 3. This is our stress 1, or stress 2, and they are within the value. Okay. So therefore, diameter should use can be equal to 1.4986 inches, or round it off to 1.5 inches. So this is how we calculate based on von Mises criteria. Sorry, Tresca criteria. Now, I'm going to show you 3 possible conditions, okay, before we finish off with Tresca, because not always, remember, we happen to discover that for this case, stress max and this expression over here is the same, right? But it's not for every condition, okay? It's only for what? Some condition, okay? And what is this some condition that this is true, okay? So if we have a scenario, right? So Tresca criteria, okay? So if we have an element and the element only see one stress state, okay? The element only is loaded in stress X, okay? So when we sketch 3D move circle, right? When we sketch 3D move circle, it looks like this. It's so straightforward. All of you will know this by now. If not, I'll start to panic. It's so weird. It worked just now, but okay, it's okay. So normal stress, shear stress, element rotate anti-clockwise, clockwise and anti-clockwise. This is our point X, our point Y, and our point Z. So what we realize is over here, okay, this line over here, this is our stress X, and therefore over here, because there's zero shearing stress, this is our point X, and over here, this is our point Y, and also our point Z, right? Because they have zero normal stress and shearing stress. When this is the case, okay, when we construct our circle, right? So this is our 3D mold circle, right? So when this is the case, right, we know that over here, this is our tau max. By the way, this is already a what? 3D what? Mold circle, yes or no? Okay, so 3D mold circle can be represented by what? One circle, okay? So we know over here, tau max is equal to stress max divided by 2. And for this case, stress max can be also equal to stress X divided by 2. Okay, so this is the one condition. Okay. The next condition we have is when we have a case where this is our element now. And for this case, we have a normal stress X. Okay. We have a compression, or we have zero stress Y. Okay. So but we have shearing stress. Okay, so we have our shear xy is equal to shear yx. Okay, and then from here, this is our x, this is our point y, and this is our point z. Now, this stress state, if you were to look at